Have you ever wondered, why does the universe exist at all? It's a question that has puzzled the greatest minds for centuries and continues to baffle us today. But science, in its relentless pursuit of knowledge, has provided us with a plausible explanation: the Big Bang Theory. Imagine, if you will, the entire universe compressed into a single point. This is what we refer to as singularity, a point of infinite density and temperature so unimaginably small, yet containing all the matter and energy that would eventually become our universe. Then, in a fraction of a second, this singularity expanded. An explosion of such magnitude, so intense and powerful that it's hard to comprehend. This was not an explosion in space, but rather, an explosion of space itself. The fabric of the universe, expanding at an unfathomable speed. In the aftermath of this cosmic detonation, the universe was an incredibly hot, dense sea of particles and energy. As it expanded, it cooled and the particles began to coalesce. The first atoms formed, then molecules, and over billions of years, these molecules came together to form the first stars and galaxies. But the universe didn't stop there. Over time, galaxies collided and merged, stars were born and died, and out of this cosmic ballet, planets emerged. Among them was a little blue planet we now call home. So, to answer the question, why does the universe exist? It seems that the answer lies in a single point of singularity, a colossal explosion, and the relentless expansion and evolution of matter. A process of creation and transformation that has been underway for nearly 14 billion years, and continues even as we speak. But remember, this is just our best understanding right now. Science is always evolving, always questioning. Who knows what new insights the future might bring? And just like that, from a singularity, our universe was born. But what about the stuff the universe is made of? The atoms, where did they come from? This is a question that has puzzled scientists and thinkers for centuries. Let's take a closer look. Atoms, the smallest units of matter, are the building blocks of everything we see around us. They're like tiny Lego blocks, piecing together to form the universe as we know it. But how are these minute building blocks created? The answer lies in the heart of the stars. Yes, the shining celestial bodies that dot our night sky. Stars are not just beautiful to look at, but they play a crucial role in the creation of atoms. In the core of these stars, a process called nuclear fusion takes place. This is not just any ordinary process, it's like a grand cosmic kitchen where atoms are baked. In this stellar kitchen, lighter atoms like hydrogen and helium are subjected to extreme temperatures and pressures. These conditions force these atoms to come together, to fuse, creating heavier atoms. Imagine it like a dance, a cosmic ballet where atoms waltz together, merging and transforming into something new. This is how all known elements, from carbon to iron, from nitrogen to silicon, are created, but the story doesn't end here. When a star exhausts its fuel, it explodes in a spectacular supernova. This explosion scatters the newly forged atoms across the universe. They travel through space, eventually becoming part of planets, moons, asteroids, and yes, even life forms. So the iron in your blood, the calcium in your bones, the oxygen you breathe, all were once part of a star. A star that lived, fused atoms and died, only to scatter these atoms across the cosmos. It's a humbling thought, isn't it? The idea that we are, quite literally, made of star stuff. Each atom in your body has been on an incredible cosmic journey, a journey that spans billions of years and countless galaxies. So the atoms that make up you, me, and everything around us were forged in the heart of stars. Atoms formed stars and planets, but how did life arise from non-living matter? It's a conundrum that has intrigued humanity for centuries. The answer may lie in a concept known as abiogenesis, a theory that life could have sprung from simple organic compounds. Now let's take a moment to delve into this fascinating idea. Think about the early Earth, a primordial world of volcanoes, lightning, and oceans teeming with chemical soup. This environment was harsh, yet it was rich in the fundamental elements of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur were abundant, swirling in a chaotic dance, waiting for the right conditions to combine. Imagine a storm, a bolt of lightning striking the ocean, providing the energy needed to spark a chemical reaction. This reaction could have resulted in the formation of simple organic compounds. These compounds, in turn, could have reacted further, developing into more complex structures such as amino acids, the building blocks of proteins. Proteins are vital for life as we know it. They are the workhorses of our cells, performing countless tasks, from building structures to helping chemical reactions occur. But if proteins are the workhorses, then DNA is the blueprint. And just as amino acids combine to form proteins, so too can nucleotides combine to form DNA. Picture these early proteins and strands of DNA floating in the primordial soup. Over time, they could have formed a rudimentary cell, a protective bubble of sorts, keeping the outside world at bay while allowing the necessary reactions to occur within. This might have been the first step towards life. Of course, our understanding of this process is still evolving. The precise conditions needed, the exact reactions that took place, these are details we are still trying to uncover. But the basic idea, the notion that life could have arisen from simple organic compounds, is a cornerstone of our understanding of the origins of life. In this way, life as we know it might have taken its first tentative steps. Once life began, how did we end up with such a vast diversity of species? This question brings us to the concept of evolution, the grand narrative of life's continual adaptation and transformation. The term evolution might conjure images of Charles Darwin, finches, and a gradual progression from simplicity to complexity. That's not far off the mark. In essence, evolution is the process through which species change over time. Often driven by the mechanism of natural selection, individuals with traits better suited to their environment are more likely to survive, reproduce, and pass on these advantageous traits to future generations. Imagine a population of beetles in a forest. Some are green, others are brown. In a lush, leafy environment, the green beetles are less visible to predators and thus have a higher survival rate. Over many generations, the population may become predominantly green, an evolutionary shift driven by natural selection. But it's not just about survival. Evolution is also about diversification, speciation. The birth of new species often occurs when populations become geographically isolated. Imagine a river cutting through the beetles' forest, separating the population. Over time, the two groups may evolve different traits, adapting to their specific environments. Eventually, they may become so distinct that they're considered separate species. This process, unfolding over billions of years, has led to the awe-inspiring diversity of life we see today. From the tiniest microbe to the largest whale, from the simplest organism to the complexity of the human brain, each is a testament to the power of evolution. Yet evolution isn't a path towards an ideal form. It's a dance with randomness, a constant interplay between genetic variation and environmental pressures. It's about change and adaptation, survival and diversity. Its rhythms echo through time, shaping life in all its multifaceted glory. And so, as we stand amidst this grand tapestry of life, let's take a moment to marvel at the intricate beauty born of this relentless process. The incredible variety of life on Earth is the result of billions of years of evolution. We've journeyed from the birth of the universe to the diversity of life on Earth, but where are we headed? A question that has intrigued humans since time immemorial, and one that continues to captivate us today. As we gaze into the future, we can only speculate on the trajectory of life's evolution. We stand at a critical juncture where the decisions we make today will shape the course of life for generations to come. Climate change, a reality we grapple with every day, is a significant factor that will influence this evolution. The Earth's climate has always been dynamic, driving evolution and extinction in a never-ending dance of survival. As the planet warms, organisms will need to adapt, migrate, or face extinction. This could lead to the rise of new species, better equipped to thrive in changing conditions. But it's not just the natural world that will shape the future of life. Technological advancements, too, will play a crucial role. Biotechnology, for instance, may allow us to genetically engineer organisms, potentially creating new atoms across the universe. Artificial intelligence could develop to a point where it becomes indistinguishable from biological life, and even life forms. As we ponder the iron in your blood, the calcium in your bones, we must also consider the possibility of life beyond our star. The discovery of water on Mars and the detection of potentially habitable exoplanets across the cosmos have opened up exciting prospects for extraterrestrial life. The idea that we are be on the brink of discovering life forms that have evolved under completely different conditions has been on an incredible cosmic journey. What we can be sure of is that billions of years and countless fascinating journeys filled with surprises and discoveries that will challenge our understanding of what it means to be alive. Stars. As we peer into the future, remember this: we are all star stuff, contemplating the stars. Our future, like our past, is intrinsically tied to the cosmos, a testament to the interconnectedness of all life.